Okay, so our first part of third quarter, we're going to start with polygons. We will move in um, a lot into the different parts of polygons, which you probably remember some maybe from junior high, but it goes a little bit more in depth. But this first lesson should be pretty basic. So we kind of jumped over chapter six. Not weird, it's okay. So that's why we go right from five to seven. So in these notes, we left off talking about different parts of triangles and the angles, and a triangle adds up to 180, and we're going to extend that now with more than three sides to a figure. So if you want to go ahead, I'm not going to read you what is on here. I think a diagonal you're probably familiar with, although I kind of learned in the past that some students do not know what a diagonal is. So a diagonal will always connect non-adjacent vertices. So in this picture, you can see, I'll move my mouse, so you can see that B and C, those are forming a side, whereas B and D is a diagonal because B and point D are not adjacent. So a polygon can have obviously more than one diagonal. It just depends on how many sides the polygon has. So we're going to focus on the first part is interior angles of a polygon. And obviously we're going to talk about the inside. So there's a formula that we can follow. And basically, if you know the number of sides, that stands for n, we're going to subtract 2 from that value, and then we're going to multiply by 180 degrees. Now, normally, this is when I would ask students in class, hey, what have we talked about so far this year that has added up to 180? And the two common answers I usually get are supplementary angles and the degrees of all three angles on the inside of a triangle. And so that last one that I just mentioned, you're going to be using that. So that 180 does come from that. But at the end of these notes, for today's work, you're going to work on your own, and you're going to kind of investigate this formula and where and why that 180 is involved. But for right now, we're just going to apply it. So in example one, it says, what is the sum of the interior angles of a quadrilateral? And yes, you need to know that there are four sides of a quadrilateral. So what we can do is we can just use our formula. And if we start with the formula, we would substitute in 4 for the number of sides. And you're probably going to want to use your calculator. I think you can know that two 180s would be 360 degrees. So all quadrilaterals, regardless if we want to call them more specific names that we'll get to later in this chapter, such as rectangles, trapezoids, squares, etc., they all are going to have 360 degrees on the inside. So a triangle, if we really think about the triangle, if you would substitute in 3 for n, 3 minus 2 is 1, and 1 times 180, so it fits with our, there are 180 degrees on the three angles of a triangle, okay? If you want to pause at any time and do the examples and then check them with me, do what works for you and the pace that works, okay? Our next examples for A and B, if we count the number of sides for A, this has 7 sides. And if we go ahead and count, we have 12 sides. And you'll be looking at specific names. Anything past really a decagon, which is 10 sides, we just really say, oh, it's a 12-sided polygon. So for 7 sides, if we substitute this in our formula, which you gotta know by now, hopefully. So if we do 7 minus 2, that would give us 5 times 180. That is 900 degrees are always on the inside of any 7-sided polygon. And then for the 12-sided figure, we have 12 minus 2, if we use our formula. And you can probably do this 10 times 180 in your head, is 1,800 degrees. So really it is that simple as far as just kind of reviewing what are the measures of the interior angles of a polygon. So if we now move on to example 3, it talks about classifying the polygon based on its number of sides. So here we're going to have to work backwards. I'm going to use a little algebra. I've had students in the past that want to guess and check, but I think at a high school level it's best to kind of use this formula. So if we start with our formula, and we know that n minus 2 times 180, where n is the number of sides, usually we would know those number of sides, like in the examples above, and just plug it in. But this time, we know that all angles of an n-sided figure adds to 720. So if you basically look at this, this is just a quick algebra equation we can solve. And this kind of takes the calculator work and the guessing and checking out of it. So if we were back in algebra, I'm hoping you would take both sides and divide by 180 to clear out that. And we have n minus 2 equals. So if you take 720 divided by 180, that is 4. And then what happens is you can see, just solve for n. So it makes it a really easy way. So we know that our answer would be 6 sides, which is called a hexagon. So I'd go ahead and try B on your own, but basically just start at that formula. And this time we know that all of the angles of this polygon is equal to 1080 degrees. So now let's just solve for n. So once again, I'm going to divide both sides by 180. And that leaves me with the equation of n minus 2 equals 6. So if I add 2, we have an 8-sided figure. So that says 8 sides, which you should know is an octagon. Okay? All right. So now what we're going to do is we're going to solve for the value. So now what we need to do is use our knowledge of how many degrees are on the inside of a polygon to help us solve for a missing value. So we know that this has 4 sides, 1, 2, 3, 4. So I know that this 4-sided figure from our first example is going to have 360 degrees. So basically, if you can at least show me the setup of your thinking, the rest really turns into calculator work. But we know all 4 angles are going to add to 360. So this is kind of our setup. And then I'm going to combine like terms. So if I add all of my numbers, I get 288. And now you just have to solve this equation. So when I subtract 288, that missing angle value, which is x, would be 72 degrees. So for part B, don't make a mistake where you're like just going to set everything equal to 360 just because that's what we did in A. This is a 6-sided figure. And if you need to use that formula, n minus 2 times 180, or some people at this point are like, oh, I remember how many degrees are in a hexagon. But a hexagon, all 6 angles will add to 720 degrees. So when we add all 6 angles, I just once again show my work. So in case you do make an error, I can help you or see where you went wrong. Make sure you set it equal to 720 degrees. So once again, I'm going to combine like terms and all those numbers, I think I added correctly. And when I solve for x by subtracting from both sides, I get 107 degrees. And we can check that by just adding up those 5 angles that were given and then add the 6th angle 107 and check it. Okay? All right. So the really second part of our notes go to regular polygons, and this goes kind of pretty quick and simple also. But a regular polygon is where we take our equilateral, and I know you all remember what equilateral triangle from last chapter. So all the sides and all the angles of an equilateral triangle are equal. Well, that's the same. So an equilateral polygon is where all the sides and angles are equal. So it's called, if you smash those two definitions together, we have a regular polygon. So right here it tells us that a regular polygon has all the sides and all the angles congruent. So for example, if someone would say, hey, what's a regular quadrilateral? Well, the regular quadrilateral, we actually call it a square because we know in a square that all four sides are the same, and we know that in a square, all four angles are the same and they're 90. But remember, those four 90s add to 360, which fits our definition of the inside angles of a quadrilateral. So if we move on, we're going to combine and look at that definition a little bit later in your work. But now we're going to focus on exterior angles. And exterior angles of a polygon actually becomes pretty easy because in an exterior angle, the exterior angle, so if you look at this picture, I'm going to circle over here. We started in this example with a pentagon. But what happens is if we do the math and look at these outside angles, they are supplementary to an inside angle. And so believe it or not, when you add up all the outside angles, 1, 2, 3, 4, 5, it's going to equal 360. And so what happens is when we start looking at other values, as the polygon gets bigger, the inside angle sum gets bigger. But what's interesting is that when you have a polygon that gets bigger, the outside angle sums always will be 360. And so sometimes students are like, huh? Why would that be? So just so you know, is even if we look at different sizes of polygons, so right here you can tell if there are 6 angles, 1, 2, 3, 4, 5, 6, that all of those 6 outside angles are also going to be equal to 360. So let's take a look at 2 examples. So in part A, we have a 4-sided figure, quadrilateral, and once again, this time it doesn't really matter how many sides, because our equation is going to be set equal to 360 because that's what all outside angles are equal to. So if we combine like terms and start using our algebra, we have 3x plus 156. As I say it, make sure you show your work. So you should be subtracting 156 from both sides and then dividing by 3. So you should get x is equal to 68. And this is the only time I will tell you that the inside angles add to 360, but so did our 4 outside angles. Now for part B, we have a hexagon. And if we were worried about the inside angles, I would have to think, okay, 6 minus 2 is 4 times 180. That formula gives me 720. But I don't do that because all 6 angles or all 20 angles of a 20-sided figure or all 80 angles of an 80-sided figure, the outside angles will always add to 360. So once again, 1, 2, 3, 4, 5, 6. I'm just checking. So we have to combine like terms and solve. So as you're subtracting 265 and then dividing by 5, your value is 19. So as we kind of wrap this up, what you're going to be doing, this last page of your notes, what I want you to do is to complete this chart on your own, and then you can check your work with the answer key that is in Canvas, posted right where this video was. And just to kind of show you, one of the parts is done for you completely, and I actually started this one. So let me explain kind of what you're going to do. So a quadrilateral, we know, has 4 sides. And then it really is going to investigate this formula that we started our notes off with today. And we know that 4 minus 2 is 2. So it's not that this chart's going to be hard, but what I want to show you is that right here when it says interior angle sum of a convex, well, it's using the n minus 2, which really stands for how many triangles can you fit inside of a polygon from one vertex if you draw one diagonal only. So if you'll notice, you'll see 1 triangle and 2. So 2 triangles at 180 degrees apiece gives you that 360. So you can tell from the next example, this pentagon was done for you. So finish up the chart and follow the work on Canvas.